So on behalf of all faculty of the IPFW College of Arts and Sciences and all colleagues beyond, good evening, everyone, and welcome to the 42nd installment of our Distinguished Lecturer Series. The lecture series was started 28 years ago, and ever since Jim like in Dr. James Farlow Jr., gave a talk on dinosaur footprints 10 years ago, the series is on the regular schedule that most of our are familiar with. A distinguished colleague from among our own ranks presents in the spring, while for the fall term we invite a nationally recognized colleague from the outside. The right to nominate an external speaker for this fall was with the sciences representatives within our college. So this is why Jim will be on stage again tonight, this time, however, to introduce our guest of honor, Dr. Eugene Scott. Before I hand things over to Jim, however, allow me to make one final remark. On one hand, as the European I am, I do not understand why there is or should be any fuss about Darwin and evolution. I mean, not more than about like Maxwell and electromagnetism, or Boltzmann and kinetic gas theory, or Wagner and continental drift and plate tectonics, and so on and so forth. On the other hand, we at IPFW seem to have hard scientific data why there must be something wrong with evolution. After all, an animal once believed to be extinct lives among us and roams freely on campus. Now, before you all start throwing rotten tomatoes on me, what I have in mind here is, of course, the mastodon. While it is extinct as a biological species, it lives on as our university's mascot. So as a very, very small token of our appreciation for making the long trip and spending a day with IPFW students and faculty, please accept this fluffy version of the mastodon. And now I will leave you all in the capable hands of Jim Farlow.
Well, when I look out over this large audience, I know you all, like I, am here to consider a very important issue tonight, a question that is of great concern to all of us, that being, will there be enough cookies afterward? And so I certainly hope there will be. Well, it's my pleasure to introduce our speaker tonight, Dr. Eugenie Scott. Dr. Scott received her undergraduate degree in anthropology from the University of Wisconsin and at Milwaukee, and her PhD from the University of Missouri, also in anthropology. And she has been with the National Center for Science Education since 1987. Now, you did not come here this evening to hear me talk, so with no further ado, I turn it over to Dr. Eugenie Scott.
Now, the gentlemen filming this are going to have a fit, but I just am so delighted with my new mammoth. I have to put it on the stage. This is just great. This is really, really fun. Thank you. Sorry, guys. Well, I'm delighted to be here. I've had a very, very fun day meeting with faculty and students all over campus, and one group after another, it seems, anthropologists and geologists and biologists and their professors, and I've just really had a very, very good time. But I'm here to talk a little bit about, as my title says, why all the fuss about Darwin and evolution. And indeed, in the United States, we seem to fuss more about evolution, as the dean mentioned, than among most developed countries. Canadian polling organization, Angus Reid Public Opinion, just this year issued a poll in which they asked respondents about their acceptance of evolution. The first question there, human beings evolved from less advanced life forms over millions of years. God created human beings in their present form within the last 10,000 years, and not sure. The Great Britain sample of their population showed 68% agreeing that humans evolved, and only 15% ascribing to the point of view referred to as special creation. Specifically, young Earth creationism, which I'll talk about in more detail in a little bit. In Canada, you had almost as high a percentage accepting evolution, somewhat higher but still small, 25% supporting young Earth creationism. But in the United States, you got a whopping 47% accepting young Earth creationism and only 35% accepting evolution. Now, international comparisons like these are not anomalous. Many other surveys have shown similar results. In this survey from the British Council in 2009, they asked a slightly different question, but still revealing, I think, for our purposes today. Enough scientific evidence exists to support Charles Darwin's theory of evolution, true or false, and so that you don't go very squinty-eyed trying to find where the United States is, we beat Egypt. There we go. We're second from the bottom. This is a matter of some concern. The discrepancy becomes even more poignant, if we can use that term, when we talk about the difference between the American public and the attitudes of scientists. In this poll from the Pew Foundation in 2009, 97% of scientists agree that humans and other living things have evolved. 97%, that is a very high percentage of scientists. You could probably not find that many scientists agreeing that the sun would come up tomorrow. I mean, the nature of science is that we argue with each other all the time. So what is this evolution stuff that Americans seem to have so much trouble with? Oh, by the way, one more little poll data here. Physicians also are pretty much on board with the science community when it comes to acceptance of evolution. Only about 18% of them support young Earth creationism, and in this poll asked in 2005, acceptance of evolution was measured two ways. Evolution happened without God's help, evolution happened with God's help. When you add them together, 80% of the physicians polled in this 2005 survey accept that evolution took place. So let us talk a little bit about what evolution is, because I've found in dealing with this issue for many years, we won't go into how many, I'd have to take off my shoes and run out of toes, but for a really long time, people don't know what evolution is. If you ask most people, what is evolution? It's man evolved from monkeys, right? Well, folks, evolution isn't man evolved from monkeys. If you really want to know what scientists think about evolution, the case is that humans and chimpanzees shared a common ancestor. And monkeys shared a common ancestor further back in time with the chimp-human branch. We did not evolve from monkeys. We did not evolve from apes. We shared common ancestry with apes. We share common ancestry with chimps. What evolution is all about is common ancestry, what biological evolution is all about. But I want to pause for a moment because I will talk in much more detail about biological evolution. But the thing is, evolution is more than just biology. I was talking today to astronomers, I was talking to geologists, to biologists, and anthropologists. The very big idea of evolution, what evolution means across the board to science, is that the universe has had a history. If you were able to go back in time, you would find a different universe. You'd find different galaxies. You'd find a different planet Earth. You'd find different plants and animals on planet Earth. You'd find differences from what we see today. What evolution means in this very broadest sense is that cumulative changes have taken place in the universe. And this is certainly true of galaxies and stars. Galaxies have cumulatively changed through time. They have evolved out of gases. which is why astronomy is an evolutionary science. Our solar system has evolved in this cumulative matter, with planets forming gradually through time from accretions of matter, and certainly the planet Earth has had its history as well. There has been cumulative change through time on the planet Earth, which is why geology is an evolutionary science. And the history of our planet has been significantly affected by astronomical phenomena. Meteors and comets formed craters, some of which can be seen today, and which had a very strong effect upon the probability of biological life evolving on our planet. When we look at the surface of the planet, we know that there have been cumulative changes. We know that the planet Earth has had a history. We know that the continents have shifted in their position during the course of the Earth's history. And we have a pretty good understanding of the mechanism that causes it, the continental plate movements and the subduction of these plates into the Earth and the rotation, shall we say, the movement of plates around because of the molten core. When it comes to biological evolution, we are also talking about cumulative change, but specifically with biological evolution, we're talking about this concept of common ancestry, that living things had common ancestors. And that's what biological evolution means. Descent with modification is what Darwin called it. And that sounds like a very archaic, sort of a nice 19th century ring to it, shall we say. But descent with modification is something that I would suggest that you are very familiar with, because you and I have descended with modification from ancestors in the past. We call it a family tree. Now, some principles coming up here. My sister Sue and I are the children of Dad. And Dad is the son of Grandpa. Grandpa's also the father of Uncle John, and Uncle John is the parent of Cousin Liz. Sue and I look more like each other than we look like Cousin Liz, because Sue and I shared a common ancestor in Dad more recently than we shared a common ancestor with Liz in Grandpa. Basic principle. The more recently you shared a common ancestor, the more similar you are. Now, Jeannie, Sue, and Cousin Liz all look more like each other than we look like you, gentlemen, because we all shared a common ancestor with each other much more recently than whenever it was we shared a common ancestor with you, because sooner or later we do share a common ancestor with you and you and you and everybody else here too. Similarity and differences are directly related to common ancestry. This works the same way with animals and plants. Bears and dogs look more like each other than they look like lions, because bears and dogs shared a common ancestor with each other that was a caniform or a dog-like ancestor more recently than they shared a carnivore ancestor with the lion and the cat group. Cebus and howler monkeys look more like each other than they look like apes, because they shared a common monkey-like ancestor with each other more recently than they shared a common primate ancestor with the apes. But bears and cebus monkeys look more like each other than they look like salamanders, because they shared a common mammal ancestor with each other more recently than they shared a common vertebrate ancestor with the salamanders. The more recently you shared a common ancestor, the more similar the descendants. Very basic principle. It works the same way. It's obviously an analogy. It's not a perfect analogy. I left out mom in this family tree, which, poor mom. But, it was an analogy. It's a simplification. But the basic idea is the same. The reason why Sue and I look more like each other than we look like Liz is because we inherited more genes from our dad. But we inherited genes from Grandpa that are shared with Cousin Liz. And in fact, genetics gives us ways of calculating the number of genes, the proportion of genes, the probability of sharing genes among various descendants. It's something that you'll do if you take a genetics class. You'll figure out these coefficients of relatedness. Same thing with living organisms. Just as genes pass through a family tree, so genes also pass through groups of organisms if you stand way, way back and look at this branching and splitting tree of life. What the tree of life really is an expression of a genealogical relationship among species and other groups of organisms, just like a family tree is a genealogical relationship among the individuals who are related. Genes are the currency of evolution. They just happen to appear in groups of organisms when we're talking about evolution, as opposed to single individuals when we're talking about a family tree. I want to present the idea that evolution is a three-part idea, if you really understand it. The big idea of evolution, which I've just talked about, is the idea of common ancestry, descent with modification. The way we study evolution is to look at the processes or the mechanisms that bring evolution about, the most important of which is natural selection, but there are other mechanisms as well, which if you take a biology class you'll learn about. And secondly, we also study evolution by looking at the patterns of evolution. We look at how the tree of life has branched through time. Now, something that's kind of interesting in terms of the creationism and evolution controversy is that creationists often will point to arguments among scientists about, say, natural selection. Natural selection, they will sometimes claim, isn't a strong enough mechanism to produce really complex organisms or really complex structures within an organism. Therefore, evolution didn't take place. Now, I suggest to you that that's a category error, because the evidence that we use to convince ourselves that living things share common ancestry is very different from the evidence that we use to demonstrate that natural selection is a very important mechanism. They are really two separate sets of data, and they don't really they don't contradict each other. They just don't really relate to each other. The other thing to think about when you consider this three-part message here is that among scientists, as you saw, 97% of the scientists from the American Association for the Advancement of Science, that was the sample from which that 97% figure came. Scientists are very strongly in agreement that living things have common ancestors. Nobody is sitting up arguing about whether evolution took place. But you don't have to take my word for it. You are at a university. It's very convenient for you to go down to the library. And I suggest you do this. Don't take my word for it. Go to the library, pick up a half a dozen or so issues of Science Magazine or Nature or Cell, PNAS, the biggies, and just flip to the table of contents and see if any of the articles are scientists who are questioning whether evolution took place. Are there any articles in there which are debates among scientists over whether living things shared common ancestor? If you find any, do let me know, because it will come as a big surprise to me. I have a feeling that I'm pretty safe in uttering that challenge to you. On the other hand, you can look at that same stack of magazines and you can find lots of arguments about the mechanisms of evolution, lots of research going on, lots of consternation about the tree of life. Does this group fit here, or does this group fit there? And that is normal science. So what we do is we argue about the details. We argue about the pattern and the process, but nobody's really arguing over the whether. Nobody's really arguing over, do indeed living things share common ancestry? But the creation and evolution controversy in the United States is really over the whether, because the public in general is very confused about this point and believes that there is, they're told by the creationists, that there is this big controversy going on within the scientific community over whether evolution took place, and it simply is non-existent. But like I say, prove this for yourself. Go and take a look in the library and see what you find out. Now, there's a very good reason why there's this unanimity of opinion among scientists about evolution. It's expressed very well by a very famous geneticist from the last century, a man by the name of Theodosius Dobzhansky. Wonderful name. He wrote an article in the American Biology Teacher, and the title of the article was "Nothing in Biology Makes Sense Except in the Light of Evolution." A very strong title for an article. Inside, he wrote this. He said, "Seen in the light of evolution, biology is perhaps intellectually the most satisfying and inspiring science. Without that light, it becomes a pile of sundry facts, some of them interesting or curious, but making no meaningful picture as a whole." Now, what he meant by that was not that you can't understand biology or you can't study biology without understanding evolution, but what he meant was that evolution makes biology make sense in that it tells you why things are the way they are rather than some other way. There's lots of ways to be an animal that moves around on Earth. In the water, you swim. You don't have quite as many. But on Earth, you have lots of different ways of getting around. You can burrow, you can walk, you can run, you can climb, you can swim, you can fly. Lots of different ways to get around. And if you look at insects do it with 6 legs, spiders do it with 8 legs, millipedes do it with a whole bunch of legs. You don't have to count. But all land vertebrates, okay? Amphibians, reptiles, birds, and mammals, all land vertebrates have 4 limbs, 2 in front and 2 in back. Why is it that amphibians, reptiles, birds, mammals, all of the vertebrates on land all have 4 limbs? They could have 6. 6 works just as well. Insects don't go around saying, geez, I really wish I had 4 legs because I could walk back. No, they don't. 4 legs work, 6 legs work, 8 legs. Why is it that all land vertebrates have 4 limbs? This is a curious matter. Well, it's because all land vertebrates are descended from an early vertebrate known as a tetrapod, 4 legs, that had 4 legs. And we actually have a pretty decent fossil record showing the transition from an aquatic vertebrate that had 2 fins in front and 2 fins in back, up to more and more tetrapod-looking creatures until finally at the top of that scale you have creatures that look pretty much like land-living forms. And this is only a partial fossil record. We have many more fossils that fill in their ranks among them. So the reason why all land vertebrates have 4 limbs is because they are descended from a form that had 4 limbs. Could have been 6. Now contemplate how different basketball would be if we had 6 limbs instead of 4. It could bring about some very interesting contemplations here. I want you to contemplate this inset, if you can read it here. The arrow shows the beginning. It says, "Nothing in biology makes sense except in the light of evolution," Theodosius Dobzhansky. This is an inlay in a floor of a science building at a major Midwestern university. Anybody know where this is? Notre Dame. Okay? If you went to Notre Dame, you would find that evolution was taught in as matter-of-fact a manner as it's taught at this university, a secular university. If you went to Baylor, you would find that evolution is taught matter-of-factly in biology, geology, and astronomy, and anthropology. If you go to Brigham Young, you will find that evolution is taught matter-of-factly in all of those disciplines as well. And all of the well-regarded sectarian institutions, as well as all of the secular institutions of higher learning in this country, evolution is not controversial. Remember that 97% of scientists agreeing that evolution took place. It's not a big deal at the university level, which is why scientists kind of scratch their heads when they look at the big controversy that goes over the teaching of evolution at the K-12 level. If we're going to understand this, we need to understand what we call at NCSE the pillars of creationism. These are the contentions of the anti-evolutionists, of the various forms of creationists. Virtually every argument that I've ever read in a book or a pamphlet or a letter to the editor can be fit into one of these 3 categories. So let's take a look at what they are. The first one is the idea that evolution is invalid science, that scientists are giving up on evolution. Well, that would come as a surprise to the scientists at this university. The second of the pillars of creationism is that evolution and religion are incompatible, that you have to choose. You can either be a good guy Christian creationist or you're a bad guy atheist evolutionist. The third of the pillars of creationism is the fairness pillar, that it's only fair to teach both. If you teach evolution, you really should teach creationism because it's the fair thing to do. Sometimes the fairness pillar is reworked a little bit as, well, it's good critical thinking. It's a good pedagogical approach to have the students weigh the strengths and weaknesses of evolution or the strengths and weaknesses of creationism and really see which one comes out. Talk about all 3 of these. Well, the first argument, that evolution is invalid science, is certainly the weakest one. They've never really been able to get very far. If you read the creationist literature, there's lots of claims of supposed scientific validity for their views. Actually, not very many scientific claims for the validity of their views. There are many more claims for the invalidity of evolution. There's actually quite a literature of analysis of these creationist claims. And if you want to take a quick look at a couple of websites, you'll find pretty much all of the arguments of the creationists evaluated here, talkorigins.org and pandasthumb.org, the latter specializing in intelligent design. Also, in National Center for Science Education's little book, Voices for Evolution, which is available on our website, or you can download the entire content. You don't have to buy the hard copy. You can find all of these online. The includes statements from a couple of dozen science organizations, everything from the very largest associations to some very small botanical associations. And all of them are in agreement that evolution is sound science, it should be taught in the schools, and that creationism is a religious view which, whatever its merits or demerits, it does not belong in science class. We also have statements and voices for evolution from religious organizations and also from educational organizations. The second pillar is the pillar that evolution and creationism that religion, Christian religion particularly, and evolution are incompatible. This relies upon the idea that the acceptance of evolution requires a choice between science and faith, that there is a dichotomous division here. You are on one side or the other. I'm curious as to which of the balloons they popped. What can we thank them for? But nonetheless, that's from Answers in Genesis. They are very generous with their graphics, for which I thank them. But the idea that there is this dichotomous divide, you have to be on one side of this line in the sand or another, I would like to suggest to you is just factually wrong. I would suggest that it's more useful to contemplate what I've called the creation-evolution continuum. Because as I've been studying this problem, it looks to me like there's not a single line. It looks to me as if there's a lot of variation from the most extreme creationists to the most extreme evolutionists. Let's take a look at the position, shall we say, on this continuum. Now, the most extreme special creationists are the flat earthers. Now, granted, flat earthism is not a movement that is very large. In fact, sometimes when I talk about flat earthism, people say, oh, come on, you can't really be serious. I am really serious. Mr. Charles K. Johnson died in 2001. He was a 20th century flat earther. He was the head of the International Flat Earth Research Association. He was dead serious about the earth being flat. His wife was from Australia, and she signed an affidavit that she never hung by her heels. That's got to be pretty persuasive right there. Now, Mr. Johnson never had a very large following. He only had a couple hundred members of his association, an inordinate number of which were physicians, by the way, and I really don't want to go there, but nonetheless. Mr. Johnson's view of the world was that it was in the shape of a nickel. This is actually a 1922 German depiction. The Bible talks about the circle of the earth. That's where these people get this idea that the earth is flat. Spheres are not, circles are two-dimensional. And the idea of the flat earth is that it's round, but the North Pole is in the middle. Actually, I was in the Minneapolis airport a while ago, and there's this wonderful inlay on the floor of the airport in Minneapolis. Go take a look at it someday, but this is the flat earth map. I don't think the people in Minneapolis intended it that way. This was just a weird projection, but this is pretty good. The North Pole is in the center, and then the continents radiate out around it. And so of course Columbus sailed around the world. He just sailed out to the edge and sailed around, so it was perfectly reasonable. Okay, flat earthism is a very extreme position. Certainly modern-day creationists do not adhere in very great numbers at all to flat earthism. The next most extreme form of creationism are geocentrists. Geocentrism planets and the sun go around the Earth. Heliocentrism, planets and the Earth go around the sun. You understand all that difference there. Well, geocentrism is a very minority group, view, to be charitable. There are not very many modern-day creationists who are geocentrists. There's a handful. But at one time, it was a very serious and strongly defended point of view in the Christian church. Cardinal Bellarmine wrote that all church fathers agree in explaining literally that the sun is in the heavens and moves swiftly around the earth, and that the earth is far from the heavens and stands immobile in the center of the universe. This is in the 1600s. And, there was this little dust-up with Galileo a while ago, and Copernicus had a tough time too. But even today, even though the Catholic Church today is fine with the heliocentrism, but today there are modern geocentrists, one of whom is Gerardus Buo, who follows the Tychonian view. If you can see in this map of the solar system there, the blue dot is Earth, the yellow dot is the sun. Notice in this drawing that the planets go around the sun, but the sun goes around the Earth. Okay, so it is a geocentric kind of universe. Buo writes, if God cannot be taken literally when he writes of the rising of the sun, how can one insist that he be taken literally when writing of the rising of the sun? All right? Now, what flat earthers and the geocentrists share is a very ancient cosmology that was shared by the early Hebrews, who of course codified it in the stories that were later written down as the Bible. In the early Hebraic conception of the universe, you had a firmament which was conceived of as a dome of metal that arched over the planet, and above the firmament was the waters above the firmament the Bible talks about coming through the windows of heaven and providing the 40 days and 40 nights of Noah's flood, and also the source of rain and so forth. Within the firmament is the sun and the moon and the stars. So the firmament is way, way out there. On the other hand, the ancient Hebrews visualized the stars as little tiny things. They did not visualize them as suns. They did not have any conception whatsoever of something like a galaxy. So the stars were, and in fact, you can find some creationists today, some geocentric creationists today, who argue that the stars are really just the size of school buses. So when the Bible talks about when the stars began to fall, it's possible because they're just, they're small things that will fall down through the sky. This is a geocentric point of view, when you interpret the Bible very, very, very literally. Now, most Christians do not interpret the Bible in this degree of literalism. Next along our continuum are young earth creationists, who are also interpreting the Bible literally, although not the passages showing the flat earth or the passages showing geocentrism, but they do interpret Genesis literally as calling for the special creation of all the various kinds of organisms, of plants and animals. Young earth creationism owes its origin to Henry Morris, the late Henry Morris of the Institute for Creation Research, who developed something in the 1960s and subsequently called creation science, which was an effort to show that not just that the literal special creation story of Genesis was true, he believed that anyway because he believed in the Bible, but that it was supportable through scientific evidence, because he was, of course, trying to convince other people as well. Special creation, of course, contrasts strongly with evolution. Evolution is all about trees. We talked about family trees, and we talked about trees that are formed when you compare similarities and differences of organisms. Evolution is all about trees. Creationism is all about orchards. It's all about the special creation of the separate trees, if you will, and then the evolution within the kind. So each of the trees in the creationist orchard would be a different kind. So there might be a cat kind, and then within the cat kind, you could have the development of house cats and pumas and bobcats and so forth. You could get evolution within the kind, but you would never have evolution from one kind to another, because the way they interpret the Bible refers to the special creation of the kinds in their present form, or with very small differences. One of the enthusiasms of the young earth creationists, of course, is the age of the Earth is measured in only thousands of years rather than billions of years as modern-day scientists measure it. And of course, this has been an area in which young Earth creationists has found very, very little support among the geological community. Young Earth creationism, as devised by Henry Morris, whose training was in hydraulic engineering, is a great fondness for Noah's flood as an explainer of planetary geology. And one of their favorite places is Grand Canyon, which is an approximately 300-long feature on planet Earth with up to 5,000 feet of layered sediments. This whole 5,000 feet of sediments, according to the young Earth creationists, were all laid down during the period of time when the floodwaters were raging throughout the earth. And as the floodwaters Noah's floodwaters gradually subsided, they laid down these, 5,000 feet of strata. Laying down shale here and granite here and sandstone here and then some more shale here and all these different kinds of layers, somehow keeping them all very tidy. It's not a wonder that geologists find this to be quite unreasonable. The whole Colorado Plateau has been analyzed by creationists in ways that modern geologists find zany, to say the least. NCSE, by the way, has a creation and evolution trip down Grand Canyon every summer. If you want to go and learn both the creation side and the evolution side, we have an awful lot of fun. So the science that was promoted in creation science, especially that having to do with age of the Earth, but also their biology as well, was analyzed by scientists and rejected. I mean, one common misunderstanding that many people have is that, nobody is listening to the creationist arguments. Wrong. These arguments have been around since the 1960s. They have been looked at, they have been analyzed, they have been shown to be empirically wrong, and so that is why nobody pays any attention to them anymore. Constant repetition doesn't get you another look. If you come up with something new, then the scientific community will look at you again. Intelligent design evolved in the 1980s and 1990s, and a couple of books were written in the late 1990s by legitimate scholars, and these were looked at by the scientific community. Scientists said, now wait a minute, here's where you went wrong. Natural selection doesn't work this way, cell biology doesn't work this way, here's where you're wrong about flagella. And all of these criticisms fell on deaf ears, and they just keep reiterating the same stuff, so they're ignored. But it is wrong to say that the scientific community has ignored the claims of the creationists. They have examined them, they have found them wanting, they have told the creationists and intelligent design proponents what they need to do to fix them. Nothing happens, so we go back to work. But not only the fact claims of the creationists have been analyzed and rejected, also the methodology that particularly the young Earth creationists use has been found to not at all match how we understand science works. Henry Morris, for example, has argued that the Word of God must take first priority and secondly, the observed facts of nature. In other words, all of his scientific observations, he is looking at through his religious filter. Generally speaking, we prefer science to be a little more objective than that. I spent some time last year at a conference in Alexandria, Egypt, and there were Muslim scientists from around the world, and I was quite shocked at the scientific conference to find Islamic scholars standing up there and reading passages from the Quran that would justify their whatever topic it was that they were talking about. They had to find something in the Quran that fit with the topic of their particular presentation. Otherwise, it would not be acceptable. Just like Henry Morris. Next on the continuum is a very interesting group of creationists. These are old Earth creationists. Now, old Earth creationists, as you probably guess, are special creationists. They don't accept evolution. They think God specially created. But they accept the evidence from the physicists and the geologists that the planet is ancient, millions or even billions of years. There's a large number of old Earth creationists, and this is only a partial taxonomy, believe me. Day-age creationism is really a 19th century view in which the 6 days of Genesis are very long periods of time. In John, it says a day is like 1,000 years to God. Day-age creationists seize upon that and say, aha, therefore, a day doesn't have to be 24 hours. So there's a big argument between the day-age creationists and the young earth creationists who translate the word for yam, the Hebrew word for day, as 24 hours and refuse to allow it to be a long period of time. They go round and round. But day-age creationism is one option. Gap creationism is another way of accommodating a more or less literal interpretation of the Bible to the facts of science. In gap creationism, they believe that there is a very, very long period of time between Genesis chapter 1 and Genesis chapter 2. And some of them even believe that there was a separate creation that then was destroyed, and then there was a new creation that came up, which is the Adam and Eve one in Genesis 2. There are progressive creationists, which are probably the majority of modern-day old earth creationists. Progressive creationists believe that God created consecutively through time. That first he created single-cell organisms, then he created simple metazoa or multi-celled organisms, then more complicated multi-celled organisms, and then during the Cambrian explosion, he created a whole bunch of different invertebrate phyla, and then later on, very, very late Cambrian, early next period, he created the first primitive vertebrates, and then he got around to fish, and then he created the tetrapods, and then he created the amniotes, and then he created lions and tigers and bears. This matches the fossil record. When we look at the geological column, this is the order of fossils that we find. And so progressive creationists want to incorporate that information, but still keep the idea of special creation. So God specially creates all of these forms. They don't evolve one into another, which is an evolutionary perspective. So the progressive creationists are an interesting bunch. Continuous creationism is kind of similar to progressive creationism, except God is sort of directly tinkering with the DNA and it's kind of a really, really interventionist, almost evolution kind of thing, except God is guiding very, very, very strongly. There's also something called evolutionary creationism, but that's really evolution. Next along the continuum, which is going to come up any minute now, I want to talk for an instant about intelligent design, not for long because there's not a lot to say. Intelligent design really does straddle both young earth and old earth creationism. The young earth creationists, you recall, made a lot of claims about the age of the earth. They made a lot of claims about Noah's flood. They made claims about the special creation of organisms in their present form and so forth. And creation science got walloped pretty hard for that. Once you make fact claims, your claims can be tested and shown to be either wrong or supported by the data. And in the case of creation science, they were shown to be wrong. The intelligent design people recognized that. They came along after the development of creation science, a decade, 2 decades or so. And what they ended up doing is concentrating on a subset of creation science. They concentrated specifically on the design argument, the idea of complexity in design, that there are things in nature that are just so very, very complicated that you couldn't possibly explain them with a natural cause. You have to explain them with the direct hand of God. So something like the bacteria flagellum, which is this interesting little motor that makes the flagellum of the little tail of a bacterium move so the bacterium can move through liquid. The motor of the bacteria flagellum is thought to be one of these irreducibly complex structures, couldn't evolve through natural selection, therefore it had to have been designed by an intelligence. Wink, wink, nudge, nudge. We know the intelligence spells his name with 3 letters. First is G. You do the rest. So intelligent design is really a subset of creation science. If you read the intelligent design literature, they don't talk about the age of the earth. They're agnostic. Some of them are young earthers, some of them are old earthers. They never talk about age of the earth. They don't talk about special creation. There's nothing about Adam and Eve. There's nothing about flood geology. There's nothing about Grand Canyon. They don't talk about a lot of the things that you find in creation science, but they do talk about a real important part of creation science, which is the design argument. There's nothing new in intelligent design, which is why I nested it inside creation science. Every argument the intelligent design people have come up with, from irreducible complexity to the improbability arguments of Dembski's, pre-existed in creation science, which is why I make it a subset. Next along the line are theistic evolutionists. Now, if you went to a Catholic school, the probability is extremely high that you learned evolution. I honestly think that more evolution is taught in Catholic schools than in American public schools. And I had a NCSE member who lived in Texas who told me a number of years ago that he sent his kid to the Lutheran parochial school so that she would get evolution. Okay? Theistic evolution is the position of Catholics and mainstream Protestants like Episcopalians, most Presbyterians, United Church of Christ, the Anglicans, many Lutherans, most Methodists, etc. It's the view that, of course, evolution took place. It was the way God chose to bring the present diversity of living things into existence. There are many, many, many different forms of theistic evolution, and we don't have time to talk about them all. But again, it is the official position of the Catholic Church, which is theistic evolution. People keep sending me cartoons about theistic evolution, which I do appreciate. That's a very theistic evolution cartoon. I didn't want to leave the physicists out, so and for the anthropologists, the caption here is, instead of starting from scratch, why don't we just use modified chimp DNA? Last on the continuum are materialists. Now, I have to pause here and talk a little bit about the nature of science before we can talk about materialism as a philosophical view. Because there's a lot of confusion about materialism, naturalism and naturalism, and it's worthwhile spending just a couple minutes talking about that. What is science? Okay, science is a way of knowing, and epistemology, if you will, if you want to use the fancy term for it. It's a limited way of knowing. It has two limitations. It's limited to explaining the natural world, and it's limited to using natural processes. Now, why is it that we have to use natural processes when we do science? Well, let me suggest to you that the essence of science, she says, filling time while she finds the cursor, the essence of science has to do with testing. Now, this is a little, I added this slide this afternoon after some conversations with some groups today. Every couple years, the National Science Foundation publishes a document called Science and Engineering Indicators, and part of it is asking about knowledge of science, public understanding of science, and one of the things they ask is, trying to find out, do people understand how science works? And they ask a little question. So we're going to have a quiz, boys and girls. Take out your pencils and pens. Now, you have a blood pressure drug, and you want to know if it works. How do you test the blood pressure drug? Here's one option. Give the drug to 1,000 people and then see how many have decreased blood pressure. Here's a second option. Give the drug to 500 people with high blood pressure, give the drug to another 500 people with high blood pressure, and then see how many have lower blood pressure. Here's the quiz, folks. How many of you think that number one is the best way to test the blood pressure drug? How many of you think number two is the best way to test the blood pressure drug? How many of you haven't voted? That many don't knows? Okay, we're going to do this again. We're going to do this again. I'm sorry. All of you don't knows have to commit. This is important. How many think it's number one? How many think it's number two? Okay. Clearly, this is a science crowd. Congratulations, ladies and gentlemen. You did much better than the American public as a whole. Only 43% of your fellow citizens understood that the essence of science is testing explanations, and the essence of testing is holding constant certain variables. Okay, That's easy. We all know this. Once you're reminded, it all makes sense. Nobody's going to vote for number one after you just think about it a little bit. But this is a very important aspect of science. And this is also why we have to restrict science to only natural causes, because we have to test our explanations, and testing involves holding constant certain variables. If you use God as an explanation, how do you control God? How do you hold constant God's efforts? Any explanation you come up with that involves God could have any result possible. God is omnipotent. He could make the grass grow higher, he could make the grass grow lower, he could make the people with high blood pressure have low blood, God can do lots of stuff. We can't limit God. That's the point. God is unconstrained. So therefore, we have to just leave him out of science. This is very different from saying that all scientists are atheists or that science is an atheistic enterprise. It's atheistic only in the same sense as long division is atheistic, okay? The word materialism or naturalism has two senses. There's something called methodological naturalism or methodological materialism, which is what we've been talking about. The fact that science restricts itself to natural causes because it's about testing and because testing is about holding constant variables and you can't hold God constant. Therefore, you leave God out. There is also something called philosophical materialism or philosophical naturalism, which is a philosophical view that says there is no God. There is only material, matter and energy components to the universe. There's no supernatural at all. There's no God, there's no ancestor spirits, there's no gods. Zeus is gone. No Easter Bunny, sorry. There's no supernatural, there's only matter and energy, material forces. These are not the same thing, okay? Now, I am quite confident that every philosophical materialist is also a methodological materialist, but it doesn't work the other way around. How many of you know who Gregor Mendel was? Come on, you all know who Gregor Mendel was. Gregor Mendel was the famous monk who discovered the laws of heredity back at the end of the middle of the 19th century. Gregor Mendel used methodological naturalism. He used only natural explanations to discover the laws of heredity. He was clearly not an atheist. He was a practicing monk. He was the abbot of his order. One can be a theist and a methodological naturalist in one's science. These two are not incompatible. Philosophical materialism is not required by methodological materialism. There are too many scientists who are theists for that to be true. Now, in the midst of our culture wars here, we have those who claim that science gives warrant for atheism. We have those who claim that science gives warrant for theism. And I think it's perfectly reasonable that my friend Richard Dawkins would say that science gives warrant for atheism. I think it's perfectly reasonable that my other friend, Dr. Collins, would say that science gives warrant for theism. What I don't like to hear from anyone is the idea that science compels either atheism or theism. It cannot compel atheism or theism. If you really appreciate and understand the importance of methodological naturalism in science, if you really respect methodological naturalism, whether you're an atheist or a believer, you have to agree that we need to put a line between science and those philosophical or religious views that we may find inspired by science. There's a difference in using science to help you develop your religious or philosophical views and claiming that science compels those views. And that is where I want to draw the line. I think science is much too important for it to be incorporated into the culture wars. We need to teach good science in school, and we don't need to clutter it up with all of these philosophical and religious views. Now, most of the, I missed, don't go away. There. This is a good system, but sometimes I have to, all righty. Let's talk about the third pillar, which is the fairness pillar. Now, You know, creationists haven't gotten anywhere in trying to prove that evolution is bad science. They are not as successful in proving to the American public that science and religion are incompatible, or evolution and Christianity are incompatible. There are too many people of faith who accept evolution and so forth. But they have been extremely successful with the fairness argument. That has probably been their most successful argument because it fits so well with American culture. American culture really likes letting everybody have its say. You know, the problem is science doesn't work that way. No matter how much you like your explanation, if it doesn't stand up to testing, you gotta let it go. And, pardon me, it may not be fair, but science is not a democratic process in the sense that we can vote in how life works. Sometimes if I'm talking before a group of biologists, I'll joke around a little bit and I'll say, how many of you, if you had the choice between voting in Lamarckism or natural selection, would vote in Lamarckism? And all the hands go up, right? Because Lamarckism is so much a kinder and gentler way of getting adaptation than natural selection is. I mean, if we could do that, we'd be happy, but you know, we can't. We can't vote on how the world works. We can only try to figure out how the world works. And even if we don't like some of the things we find out, we have to be honest about it. So it's not a matter of fairness. We really ought to be teaching science. Now, sometimes this fairness argument is couched in terms of, well, there are scientists on both sides. So why can't we teach both? There's a somewhat snarky lawyer's crack about expert witnesses. For every PhD, there's an equal and opposite PhD. I have been quoting the snarky lawyer for a number of years on this, and everybody chuckles just like you do. Imagine my surprise when I found that there's even somebody who's put out a T-shirt with this on it. But notwithstanding, the point I wanted to make is we have Richard Dawkins on one side, Michael Behe on the other. Well, you know, one is for, one is against. Why not teach both? Well, when you look at the number of people over here on the evolution side of things, and the paucity of people who actually, of scientists who actually support these intelligent design ideas, it becomes totally unreasonable to say that this is an equal fight. A number of years ago, we got annoyed at the Discovery Institute because they published this 100 scientists doubting Darwin. We thought that was really dumb. So we got 200 scientists signing a statement about, some of you know where this is going. We got 200 scientists signing a statement about evolution is really important, it should be taught. And all of those scientists were named Steve. And Project Steve has just been the gift that keeps on giving, I tell you. 1% of Americans are named Steve or Stephanie. You Stephanies with a PhD, come see me. 1% of Americans have the name Steve or cognates, which means every one of our Steves is worth 100 of theirs. Now, after many, many years of laboring, the Discovery Institute is now up to 700 scientists doubting Darwin. We just celebrated our Kilo Steve last February. The 1,000th Steve received his T-shirt. It's got the statement on the front and it's got all the names of the Steves in the back. It's just, you could be a rock star, just be an NCSE Steve. The 1,000th Steve, by the way, was the distinguished botanist from the Tulane Botanical Center, Steve Darwin. Just the way it worked out. So, you have to be real careful of the fairness argument. It really is not very valid. Well, where are we today? One of the problems that we're tracking at the National Center for Science Education is something called academic freedom legislation. And over the last several years, there have been quite a few of these not totally identical, but generally quite similar bills introduced into state legislatures around the country. All of them have died in committee, thankfully, except for the bill in Louisiana, which unfortunately did pass. Now, the academic freedom bills are marketed as giving teachers the right to teach all the evidence. All the evidence is code for teach evolution and creationism. In some manifestations of the academic freedom approach, they're arguing, we'll teach evolution, but balance it with the teaching of the evidence against evolution. Now, after the talk, I'd like all of you to come up to see Jim and ask him for his list of evidence against evolution so you can start teaching it tomorrow. You have that list in your pocket, I assume? No, of course not. Scientists don't have lists of evidence against evolution. That's only in the creationist literature. So this is a way of teaching creationism without calling it creationism, because the legal history of creationism has been very bad. Because creationism is a religious idea, to advocate it as opposed to teach about it, to advocate it in the public schools mean you are advancing a religion which is in violation of the Establishment Clause. So in many of these academic freedom approaches, euphemisms are used for to try to encourage the bringing in of creationist material. In Ohio, for example, a few years ago, the standards originally argued that students should critically analyze the evidence for evolution. What this meant was students should criticize evolution. It was not critical analysis at all. When the people who drew up the lesson, the classroom materials for that particular standard, they were all about intelligent design and all about the weaknesses, so to speak. Evidence for and evidence against evolution, which, as I say, is not something you're going to find in the pockets of the biology professors or the geology professors. Strengths and weaknesses of evolution comes from Texas. Evolution as theory, not fact. I could talk for a long time about problems with the word theory. It's a term of art and science. It does not mean guess, folks. And when we talk, of course, evolution is a theory. Theories are so much more important than facts. But that's not the way the public looks at it. Teach the full range of views about origins. Well, yeah, what do you mean by that? Does that mean gradualism and punctuation? Or no, that means the full range of views means you teach evolution and creationism. So all of these are ways of trying to slip underneath the First Amendment radar and get creationism in. In other words, teaching bad science in the name of fairness. Well, so that we hopefully have a little bit of time for questions, let me give you a little information for where to go for additional information. Our website is ncse.com. If you go to this little button here, you can sign up for a Friday electronic newsletter, just a little bulleted list of sort of what's going on in the creation and evolution controversy. Glenn Branch draws this up. It's an excellent job. It's full of very interesting reading, lots of good links. If you go to the news button here, it'll take you to this page where you can sort either by state or by year, find out what's going on around the country in various ways. This is a very useful site if you're writing a term paper on the creation and evolution controversy. You'll find that most useful. And of course, we are a membership organization. We'd love you to join. We have a Facebook page, of course. Like all right-thinking people, do visit us on Facebook. And even the old lady is on Facebook, so we have that as well. I thought the pearls were a good touch, didn't you? And we also have a YouTube site where we have lots of fun stuff for you to see, including clips of the Texas Board of Education hearings, where you can hear Texas Board of Education members like President, what was his name? McElroy, talking about someone's got to stand up for the experts. Excuse me. I blew that line. Someone's got to stand up to the experts. It wasn't as benign as it sounded first way. Anyway, come see us at ncsc.com. You'll find lots of information at the website and at the terrible YouTube site, NatSend for Science Ed. That is just horrible. It's not my fault. Thank you so much for coming out and hearing me tonight.
Well, we do have time for questions, and I believe there are microphones circling around somewhere. One in the center. Okay, now, and there are microphones there and in the center. If you have a question or a comment, but I will ask you one thing, please make it brief. Please do not make excessively long speeches or anything like that. And with that being the case, I'll turn it over. And if you wish to ask a question, I'm going to ask you to step up to one of the microphones to do so that everyone can hear your question. Right, and so the recorder can pick up your words.
I'm an engineering student, not a science, but I'm wondering, what is, in your opinion, is the best toolkit that we have as scientists to address creationism, and what is the worst tool that we could have to address creationism?
I think a really important toolkit is just to make it really clear, if I can quote the school board, the strengths and limitations of science. I presented science as a limited way of knowing. We're limited to explaining just the natural world. Science isn't going to tell you about the nature of God. And we're limited to using natural causes. That leaves plenty of room for faith, plenty of room for religion. It just so happens that if you are using revelation, whether not revelation in the sense of the last book of the Bible, but the idea of revealed truth from sacred sources, whether from the Hindu Vedas or from the Christian Bible or from the Quran. If you are using revealed truth from a sacred source to explain the natural world, you're not going to do as good a job as science will. I mean, sorry, that's just the way it is. It's been shown over and over and over. This process of science where we're coming up with a tentative explanation, testing it, keeping what's good, refining it, testing it again, tossing out what doesn't work, worrying away at it until we come up with something that seems to really do pretty well, but maybe somebody will knock that down too. That works a lot better than going to a sacred text if you want to know whether the earth goes around the sun or the sun goes around the earth. So if you render unto science, so to speak, that which science does best, which is explain the natural world, and leave to philosophy and religion the issues of how we treat each other, what's important, what is the meaning of life, what is the purpose of life. Those are not scientific questions. And then if you can sort of establish that, and I think most people can agree that that's not an unreasonable way of doing things, then the question is, what category do you put, quote, origins? I hate to use that term, but what category do we put a topic like evolution? I would make that part of the natural world. It seems to me that explaining the diversity, the difference between butterflies and spiders, or the difference between mammoths and mastodons. If you're trying to explain these differences, do you use religion or do you use, this natural process, this empirically oriented process of science? It seems to me to fall better within science. And so I think if we have a better understanding of how science works, that's the first thing. But of course, to me, the most toxic component of the whole creation and evolution issue is this idea that this dichotomy, that you've got to choose, that you're either an atheist evolutionist or you're a creationist Christian, and I hope I've demonstrated that there is actually a continuum, not a dichotomy here.
When you talk about the historical science as opposed to observational science, doesn't, first of all, creation and evolution fit into the historical science where assumptions have to be made? For instance, with carbon dating, you have to assume what was in the atmosphere back then in order to perform the carbon dating. So there's assumptions involved in evolution to have the same evidence that the creationists have. It's just the different assumptions that you hold to in the past. Because we weren't in the past, nobody was in the past. So in actuality, evolution and creation both fit under historical science where assumptions are involved. And that being said, with your with what you had up there about your control group, how are we going to have more creation scientists out there if all that's being taught in the schools is the evolution theory on how everything came about?
Well, that's, I'll answer your second question first. If creation science is a valid way of understanding nature, then people will start practicing it. It hasn't been demonstrated that it is. The folks at the Institute for Creation Research have been going down to Grand Canyon for 20 years now to try to prove that the nautiloids in Nautiloid Canyon were the result of a mass kill. They have not convinced anybody. And that's just a tiny little example. I think you're, what this issue really is all about is, what do you teach in high school science? I think your suggestion is we should be teaching creationism as well as evolution, because that will generate a body of new creation scientists to go out and make these discoveries.
Plus, because they were both, it's both based on assumptions
We'll
of the
get that. We'll get to
history.
that second. That's your second, the other part of your question. What a high school teacher does is, let's just take biology, is look at the whole span, hold still, look at the whole span of biology, which is a huge, huge field, and say, okay, what can we cover in a one-year course? Well, we obviously can't cover a whole lot of stuff because it's too complicated. Students don't know the background. What are the really important ideas in biology that I'm going to take from this whole big canon of understanding? And then from these most important ideas in biology, what are the ones, how do I break this down so that beginning learners can absorb it and understand it and build on their knowledge? Okay. So basically what a biology teacher has to start out with is the consensus view of science. It's the job of the creation science or intelligent design proponents to enter that consensus not at the high school level, not at the level of the high school teacher, but at the university level. It's their job to demonstrate to the scientists here and elsewhere that their approach helps us understand nature. Because science is very practical. If you can help us understand nature, sit down, we'll have a chat. Thus far, they haven't done that. The burden of proof is on them. If they do that, if someday in the future it turns out that ID or creation science or some new iteration actually is useful scientifically, fine, it'll trickle down to high school. But what they've done is they've targeted the high schools because the high school teachers are in a much more vulnerable position. It's really the ultimate unfairness when you think about it. When the rest of us want to build a scientific idea, we have to come up with the idea, we have to test it, we have to write some papers, take it to our professional meetings, try to persuade our colleagues that we've got some good ideas here, get some other people researching in the same field. We have a bigger symposium next year, we start submitting papers to journals, they get rejected, we take them. How many people in this audience have ever submitted a paper to a professional journal? Raise your hand, damn it, and keep it up, all right? How many of you have had all of your papers accepted? Leave your hands up. Okay, it's a tough world, all right? So no, they don't promise you a rose garden in science, right? So we have to go through all this work, and then only if we're really good, only if our idea actually helps progress our astronomy or biology or geology or whatever, do we get into the textbooks. That's not the way creationists do things. They write the textbooks first and then do the research later, maybe if they get around to it. So that's ultimately the unfairness of creation science. As to your understanding of the nature of science, the division between historical and, you use the word observational, the intelligent design people use operational science. It's basically the same thing. This is actually a false distinction from the standpoint that I've been talking about science today. Science is about testing. The kind of very simple test that I showed you with the blood pressure medicine is a direct test. And everybody can understand that. That's why I used it. There are lots of research designs. They all involve testing. They all involve control of variables. You don't always directly control variables like we did in this very simple example. Sometimes your variables are controlled statistically. Sometimes they're controlled observationally. There are lots of different research designs, and they really don't vary between fields like astronomy, geology, and biology. All of those are historical sciences. And they all are real sciences, and they all really do test their variables, and they all really do come up with explanations. There isn't a big difference. You talked about assumptions. I would like you to give me an example of a science that does not use assumptions. Not just evolutionary biology and geology that use assumptions. Every science uses assumptions.
But it's control. You can test it and retest
Exactly.
it on the current, on the current atmosphere, on the current Earth, on the current what you have now, as opposed to I don't know what I had then. We'll just assume what the atmosphere was.
Do you think it's not? Is it your understanding that you cannot test hypotheses about the past?
You can test them.
Okay.
My thing
Then
is,
we're in business.
if you're assuming, if the evolutionists are assuming and then doing tests and using the data from those tests already based on an assumption, how is that more valid than the creationist also having an assumption, doing tests? It's a theory as well. Why can't our kids have both theories taught in school if they're both based on assumptions? They're both done with real observational science based on those assumptions, and they come to different conclusions.
Can you give me an example of a creation science study that's based upon real observations and real theory?
Mount St. Helens erupted in 1980.
Correct.
Correct. The rocks were tested, and they came out, we know when it erupted, and it came out to be thousands to millions of years old on a rock that we know when it was formed.
I don't understand how that demonstrates creationism.
Because
I would be curious about
that demonstrates that the testing that was faulty. I mean,
if that were true, and I don't know the specific example, unfortunately, with creationist literature, you learn to not trust and verify. But assuming that that they tested molten rock and they got some anomalous state, all that would do is prove that evolution didn't happen. How does that prove special creation?
Right. No, that's what I'm saying.
But how does that prove special creation?
It just proves that whatever was used can vary, so it's not so solid. And so you teach both points of views because evolution is a theory, like you said.
It's a theory.
So why not teach both sides?
Because you have not convinced us that there is actual scientific theory in creation science.
Just scientists?
The scientific community. And I'm
that
sorry.
have been brought up to learn evolution throughout their lives, and nothing else?
It's not a matter of just being brainwashed. There's a reason why 97% of practicing scientists accept evolution. It is good science.
Taught that.
And I think we should move to the next.
Yeah, I do think we should give other persons a chance. So I've been paying attention to people, and I know those two women were here before the gentleman there, and I will continue in maybe shorter answers. And so if we could have the next question, please.
Hello. My question is related to something that I don't know if you covered, or maybe you've kind of alluded to it, but what do you think the solution to this problem of evolution not being taught in the school systems actually is? Because I think it's easily seen that no one is going to be convinced either way. Everyone kind of has what they think is true. But for me, I grew up in a very conservative Christian environment, and going to college, learning, having the opportunity to learn about evolution changed the way that I thought. And so I'm wondering if both sides were taught in K through 12, if that would maybe be helpful, or if you don't think there would be enough regulation with the teachers or something like. I'm not sure what I'm trying to ask, but I think I'm kind of getting hopefully my thought across.
I think you are a very, very good example of why the fairness argument resonates with Americans.
Okay.
It makes no sense from a scientific standpoint. It makes no sense from a pedagogical standpoint. Why would we teach students in a science class ideas that are not considered scientific and that are not considered...
I think that evolution should only be taught in schools.
Exactly.
I'm not saying that. I'm just saying maybe it would at least get evolution into the schools.
No.
That wouldn't work?
No.
Okay, I was just curious as to what you thought.
But your initial statement was, well, people have made up their minds, but then you gave us a very good example using your own condition of someone who did change their mind. I don't think that people's minds are, I think there's three kinds of people. There are the people for whom evolution is not a problem, and that's fine, they just want to learn more or less, or they don't care. There are people for whom evolution is a really big problem, and because of their religious beliefs, there's just no way they're going to budge. I think most Americans are someplace in the middle. Mm-hmm. They don't belong to religious traditions that require them to choose between their faith and evolution, but they also don't know very much about science.
Yeah,
and we need to get information to those people.
So is the problem, so the solution to the problem is just education, basically?
That's a big solution to the problem.
Okay.
That's a big solution.
Thanks.
And another thing that I wish would happen is that the mainstream clergy would talk a little bit more about creation theology in adult Sunday school class, and let their parishioners know that if they're Catholics or mainstream Protestant, evolution's okay with us. This comes as a surprise to some people. Yes, ma'am.
Earlier you mentioned how evolution crosses disciplines. Can you therefore comment on the evolution of non-life to life?
The origin of life is not really an aspect of evolution. That's a separate scientific study all in of itself, a very interesting one. But what evolution is all about is once you get a replicating structure, what happened? Special creation view is that all things appeared in their present form as we see them today all at one time, or if you're a progressive creationist, through time. An evolutionary point of view is once you get a replicating molecule, you get a radiation of those organisms into new zones and so forth. The origin of life, there's some very interesting work going on in origin of life. Today, as we speak, whatever the today is, the 8th of September, 2010, is going to be on some sort of television show years from now, so that's the date. It is the case that scientists do not have a consensus among themselves as to how to go from inorganic molecules to a replicating structure that's enclosed within a membrane. We've got a lot of pieces. We're pretty good at going from inorganic to organic. We kind of know how that works, and we have a lot of stuff about organic chemistry. We've got some very interesting ideas about how membranes form, because they're basically lipids, and there's hydrophilic and hydrophobic lipids, which are molecules which basically form lipid-like structures. A double-walled membranous primitive membrane. In terms of the replicating structure, there's some very interesting work which I don't follow closely. Some of you have heard about the RNA world that might have preceded the DNA world. There's been some speculation that there's a PNA, a peptide nucleic acid world, that preceded the RNA world. The fact of the matter is that in origin of life, you've got a lot of places where you could say, yes, by golly, this is definitely life. But what about something that can, like RNA, that can reproduce itself and sort of catalyze, catalyze new versions of itself? Is that really life? That's kind of a primitive metabolism, but is it really life? Well, no, not really, because it's not in a membrane, but it's kind of, it's sort of, you got a lot of iffy stuff. And we have a lot of pieces, but indeed, right now we don't have a consensus for going from this extreme to that extreme. That doesn't mean that we won't someday, or we may never.
Just, first of all, thank you very much for coming tonight. Ben, you had alluded to the idea that putting these philosophical implications, for example, philosophical naturalism, to the side and just concentrating on the methodology and what we can actually know about the natural world was the way to go, and you even promoted that as an effective political strategy. And I'm just curious what your response is to the counter-argument that I'm sure you've heard from some secular and atheist organizations, that is too weak of a strategy. That is, even if you say that in, for example, a school board meeting, they'll just come back with, as you've acknowledged tonight, a bunch of lies and misrepresentations about, oh, well, but this really does talk about the natural world. This really is good science after all. So that therefore, maybe that's not the most effective strategy or the most aggressive strategy that we could have. So how would you respond to that counter-argument from them?
Well, what I was recommending is that we increase our understanding of science as a way of knowing. And we distinguish how science differs from other ways of knowing and hopefully render unto science what it does really well, which is explain the natural world. It was partly a philosophical point as well. But one problem that many anti-evolutionists have is they believe that their child will be taught science and their child will therefore lose his faith. And this is a matter of considerable concern to them. I don't think it's the job of the schools to encourage the loss of faith. I think it's the job of the schools to educate children. And that if you can assuage some of the parental concern about what's actually going on in school, this is all to the good. I mean, you know, I have met teachers who just tear their hair because parents come into the back to school night thinking that, you know, Mrs. Brown, the teacher, is going to be cramming evolution and atheism down my child's throat. Well, I don't know any teachers who do that. They just teach the science. And so if we can maybe increase the comfort level for people learning science, a very interesting thing happens. They learn the science and find out that it's really interesting and that it's not as scary as they thought it was. And I think that's all to the good. Thank you so much for coming, and it's cookie time.
Oh, not quite. One more thing. One more thing. As if we haven't given Dr. Scott too much for her suitcase already, we would like to present her a plaque on behalf of the School of Arts and Sciences for being here.
Thank you very much. This is very nice. Yeah, this is very nice indeed.
Now, I believe the books are out that way, and I believe the cookies are out that way.
We know which is going to be the bigger line. This is very nice.